All right. Don't worry, I'll switch back to English in 1 second. So, 皆さん、こんばんは。私はクリス・ルシアン。毎日で2700日にドゥオリンゴで練習しました。日本語。ありがとうございます。後で練習に助けてください。All right, hello everyone. I'm Chris Lucian. I'm the director of software development at Hunter Industries. We do kind of irrigation IoT products and things along those lines. I will be speaking about bridging silos between departments using causal loop diagramming for cross-disciplinary insights. And so I'll tell you a little bit more about what that means in a second. I'm sure that everyone has to deal with communication silos. And I think it's even more prominent between other departments that maybe you're working toward the same goal, but you don't work on the same metrics or the same things that you care about. And you might not even know what the other department cares about. And this is kind of a story of how we overcame that barrier. This kind of all started during the COVID pandemic, and we're a manufacturing company. And during that time, there were a lot of orders and a lot of back orders. And so I had remembered the book, The Fifth Discipline. And specifically, there's an exercise in the fifth discipline called the beer game. And in this game, they talk kind of about the following. There are delays and what are called the bullwhip effect. And so often agile teams really want to be lean and run with lean inventory. And even in manufacturing, from sort of like the Toyota lean manufacturing and other things along those lines. In the context of muda and waste, you have inventory waste, excess inventory waste. And so a lot of companies reduce inventory. And so we saw a lot of shortages during the pandemic. This then leads to people buying or ordering more products and that product going on back order. And you get what's called the bullwhip effect. And the bullwhip effect is when people overorder and then they binge product and then they fill up their own inventories and then they realize they've taken too much inventory. And in order to balance that inventory, they stop ordering. So to the manufacturer, it looks like a huge improvement, but later it causes a lot of problems and possibly creates bad decision making. So we read this book together as leadership team on the team that I'm on, which is a group of executives. So we went through this whole experience, and what we found was that the beer game helped us a lot when we were talking about it. Gave us a way to identify when the bullwhip was happening by saying, oh, that's the beer game. Because the beer game had kind of the manufacturer that sold to a distributor that sold to a convenience store that then sold to an end customer. And it was remarkably similar to the or the distribution of irrigation products. So that allowed us, there was a lot of trust in the contents of the fifth discipline book. And one thing that the author puts in the very end of the book is a comment on causal loop diagramming. And that's kind of how we got to the point where there was trust in the system to create causal loop diagrams. And so I wanted to do an experiment where we would get together and draw. And so it was kind of organic, but what happened was I drew many causal loop diagrams on my own to practice and to get really good at it. I just drew them over and over and over again, tried to figure out how they work. And then I pair facilitated every person in each other department to create one of these diagrams separately. So we just modeled their current context. And then we went on to share and connect those diagrams. And what was remarkable was it shifted millions of dollars in funding because we realized the impacts on one diagram had effects on another diagram. And I'll show you how that worked out. This is a website called Loopy from Ncase. And so I'll share the link in a second, but kind of like the animations. And so in this diagram, it talks about good code and bad code. I've translated the other slides, so don't worry. But what matters here is that you're kind of seeing the movement in a system. And you see some circles growing and shrinking. Some of them look like they're breathing. Some of them look inert or dead. And I'll kind of talk about why in a second here. So first, we'll talk a little bit about how to draw them, and then the story of connecting them. And then I will end with some slides on how to facilitate them. Everybody has some paper or should have some paper by them, and you can draw. And when I get to the final slides on how to facilitate this process, if you can, follow along, and then I can answer questions, and you'll have better questions, I think, for me. So the first place that we want to start is with quantities. Each one of these circles will be a noun or something you can count. The quantity will increase or decrease. And in the case of the simulation, which I don't want to put too much emphasis on the simulation, it's just that the simulation is fun to look at, but it's not necessary. You can do this with just a piece of paper. So, hello. Oh. You can kind of see here, we have population, we have births, and we have deaths, right? And this is something that we care about. Now we draw the inflows. The inflows, so you can see that births lead into the population, and there's a little plus sign saying an increase in a birth, the number of births that increases, the number in the population increases. And then similarly with deaths, the number of deaths that happen, there's a minus sign, and so the number of the population decreases, right? So we're talking about quantities of either events or items or things, right? And then we draw in the outflows, and we're keeping the diagram very simple here for example purposes. In this example here, we have the births, then once the birth increases, that will then increase the population. And so you can kind of see a loop there kind of forming, and we'll get to that in a second. But also you see that the population increases, and it also means that with some delay, there will be a decrease in the population or a death, right? So the death will increase because the population increased. If you have more population, you have more deaths. That's when we talk about reinforcing loops. So in this case, you have this idea of, because you can see that the number of plus signs or minus signs are equal, it's a reinforcing loops. So again, going back to math, like a minus times a minus is a plus. And so if you have an even number of minus signs in the diagram in a loop, it's also a reinforcing loop still, even though there are minus signs. And what's hard to understand about this is that every time you go across this loop, if it's completely unchecked, what do you get? You kind of get cancer, right? Like it grows and grows and grows, and it grows exponentially. And so because cells divide, because reproduction happens based on the number, it's an exponential effect. It grows, right? And so that's why things are, that's why deaths in this case are also important. So you have a balancing loop, and that's because there is an odd number of minus signs in this loop. So in this case, 1 is an odd number. And so every time you travel through this loop, it is reducing the overall system. So you get, the final thing we want to add here is delays. And when you're drawing your diagram, you're going to use 2 vertical lines to indicate a delay if you want to increase the length here. And so this is kind of what this ends up looking like. And this is a model of the system, and not all system, no system is perfect, right? But some are useful. And so this is something that we end up paying attention to. So you can kind of see that, you know, some of the circle around deaths are growing and shrinking. And part of the reason for that is that you get a increase in the number in the birth rate, and then that increases the number of deaths. The deaths then, and so what you're seeing is the bullwhip effect here. You're seeing the growth and the shrinking and the growth and the shrinking, and that's because it's kind of an irregular system at the moment. So that's among some of our insights. So later I'll have additional slides on what that might look like, but I want to kind of talk a little bit more about the story and then get back to this. So, you know, say you have that population diagram, but you also have something related to population, and say that the related diagram also has a population. The idea is, can they connect, right? Because then you may be able to change something in one diagram to affect the quantities of another. So here's the story. So we have a tale of 2 diagrams here. And so I used a tool called draw.io. You can use Visio, you can use pen and paper, whatever you want. But I facilitated this. I didn't want to use the whole animated thing because it's too distracting to somebody who doesn't know what's happening. And also, one of the first questions I get is, how do you adjust the value of an arrow? And so leaving the arrows out of it, I think, is important when you're facilitating. In these 2 diagrams, the one on the left was kind of from a marketing position, and the one on the right was from a software team position. And these 2 diagrams were drawn independently of each other. And you could see, and I'll just talk a little bit about this, but when there are early escalations to the development team, so this is the development team's diagram, and the interesting bits are highlighted in red, you can see that all of a sudden, the capacity for the team to write more software and create more product is reduced when calls end up getting to the development team before they should, right? And this was drawn by people that know that context. Now, in this sharing session of 9 other diagrams, you have the other side of it, and this diagram completely independently came up and was almost on the same topic, but from the other perspective. Hey, our queue length gets too big because the number of technical staff available to answer those questions is not high enough, and therefore calls are getting to executives, to product owners, and to developers, which is disrupting the whole business. And so you look at these diagrams and you try and identify points of leverage, right? And say, how do you balance this, in the sense that you need to identify where they connect and then change something. So the company wanted to create more product, right? And the people that were being disrupted were budgeted to get additional staff, right? Had they gotten additional staff, then it would have likely led, given the mythical man month idea, likely would have led to additional bugs and additional problems. And then the problem would have just gotten worse because the queue would actually get longer, right? And so you'd have this reinforcing loop, and it would create a problem where the system would then further impact executives and product owners and developers. So if you go back and look at this diagram one more time, if we can attack the queue length and invest there, we can actually get more product done. We could create more products. And this was a huge revelation because I think that the people in the marketing side looking at this diagram were identifying a way that they could help, right? But the way that they could help was not necessarily, or they were in a situation where they could not control it. And the immediate thought was to add to the development team. So the shift was have technical staff be able to answer questions faster so they don't get dropped from the queue. And this might be, since we're an irrigation company, this might be a question about irrigation and how long should I water? Hopefully that doesn't get to your software developers. So that's about identifying points of leverage. So when I originally drew the causal loop diagrams, I had, it was just focused on my department. I said, oh yeah, I know this model and it's good to get my thoughts on paper and it's interesting. But the real power was when it was many departments, right? A lot of different groups showing the diagrams to each other and connecting them, because now you can say, what is my relationship with these other people and how can I affect their core metrics or the quantities that they care about? So let's draw together, and just checking on how I'm doing on time. So I will kind of walk through the questions that I asked each of these people to facilitate with them. And then we can maybe discuss afterwards if we have the time. So I'm going to use, in this example, a little bit different than the last one. I'm going to use this example of the Yellowstone National Park, which was, this is featured in a YouTube video, and it's called How Wolves Can Change Rivers. So the first thing I ask is, I sit down and pair, and this is after you've gotten a lot of practice drawing them on your own, because you want to be very familiar with the tool. You don't want them to think that you're wasting their time. And it helps a lot when you know ahead of time. And I realized this when I've tried to draw these with other people before. They were getting stuck on, what does the double line mean? How do you identify the loop, all that stuff. So you want to be a master at drawing these quickly. And then the first question you'd ask is, what's the most important quantity to you right now? In the Yellowstone example, healthy foliage would be kind of what, or healthy plants, right? And so you can see here that the rivers were actually not flowing properly because the land was barren. So if you look at the bottom picture, it is, a lot of brown, and the top picture is kind of the story in the end here. And so the second question I asked then is, how does that quantity affect other quantities? And so then you might get something like this. Well, healthy foliage increases the number of rabbits, right? And it also contributes to a stable ecosystem. So you draw these and you kind of say, does it increase or decrease? And that's where you put the plus or minus. Then you ask, how is that quantity, the one you care about, affected by other quantities? And you get the inflows. You start drawing those inflows out. And actually going back here, you'll already kind of see some things here. And because there's one rabbit and there's one unit of foliage, right? The rabbit is eating the plants. The plants are shrinking, but then there's another system at play that's hidden, which is the plants grow over time. And so then it grows, and then once it's grown enough, the rabbit will eat it, right? So what happens when rabbits reproduced, right? So the question is, do you see a balancing loop? And again, I'll go back to the number of minus signs in the loop is important here. An even number is a reinforcing loop, an odd number is a balancing loop. So because we see one line here, we can see that balancing loop happen. So you can kind of label it. Whoops, sorry. You can label it and you can kind of see the system that way. And you say, do you see a reinforcing loop or any, with an even number of minus signs? So you might expand the diagram more, right? So actually, if a well-fed rabbit will probably reproduce more, and so you'll have more rabbits, which will then want to eat. You can kind of see things get more erratic here, right? And a runaway system like this is, can sneak up on you because again, these items are exponential. So, and if you've seen an exponential curve, it starts very gradually and then it gets crazy very quickly. And so this is kind of one of the things where projects come to a grinding halt or something along those lines. So you also want to add delays, right? So then you ask, are there any delays and how strong is the loop? And the tool to reinforce the strength of the loop on this particular tool, you might draw a thicker line on paper. In this tool, you need to have additional cycles, right? And so the big loop on the outside here, I put that there in order to demonstrate the foliage growing, right? So the plant only has a fixed rate of growth. And so what you can see now, very similar to the picture of the brown landscape, the stable ecosystem is essentially non-existent, right? Because it's just being overfed, okay? And of course, some of the rabbits would die off and then these rabbits would all be dead too because they would have eaten themselves out of all of their food. So what quantities can we introduce or identify to, either strength or duration to impact the system? Well, you can add carnivores. And if you go watch the video at the Yosemite National Park, essentially did this. They added wolves. It was deer, not rabbits, but they added wolves into the ecosystem, and then the direction of the rivers changed based on that. So we can go to questions or show diagrams or talk a little bit about that if everybody would like to. And oh, hello. Thank you very much. We have a bit of time, so it would be good to.
If any have questions, please speak.
Or sharing diagrams.
日本語でも大丈夫なので、誰か質問ある方いらっしゃいますか？オンラインの方でも大丈夫なので、誰か質問ある方いらっしゃいますか？ Does anyone?
Thank you, Chris.
Thank you.
Very, very interesting topic. And you showed the causal loop diagram you made for your company, but it was so detailed.
Right.
I didn't have it end from the back. I couldn't see very well. I was wondering if you are able to talk about it in more detail and share some of what you learned from doing some more of what you learned from that diagram.
Yeah, so yes, thank you. In this diagram, you'll see a lot of pluses and minuses, as well as the double vertical lines to indicate delays, right? And so if you have a dropped call, like just for any company, you will have a reduction in brand loyalty, right? And it happens slowly over time. And so there are impacts to those sorts of things. You also have dropped calls going, you can see on the top right here, when you call the wrong resource, then that might mean that technical staff gets calls. That might mean that sales managers get calls, those sorts of things. And that just pulls away from the capabilities of the rest of the company. So you can see and hear how the different parts of the system interact. Once that happens, then that cascades to other people throughout the organization, eventually landing, I think, a lot of the time with the software developers, which reduces the number of bugs that can be fixed. And so it's not, this is just the system of that one department, and they don't realize the impact of those things because they just say it's a dropped call. No one sees the hidden effects until you find the other diagram and you say, oh, there was an early escalation. So the speed of response to the customer goes down, which means the customer happiness goes down. That's kind of mirrored in the same way in this diagram. But at the bottom half of this diagram here, you see that there is an addition to developer troubleshooting that creates more developer thrashing, meaning the developers are shifting priorities regularly. That increases developer stress, that reduces feature velocity, and that then a reduction in feature velocity. You can see the following arrow at the very bottom. There's a delay and a plus sign. So if developer thrashing reduces feature velocity, then the plus just makes the sign continue. So it'd still be a reduction in the number of releases. And you can then illustrate that as a balancing loop, which is right here. It's the balancing loop on the far side there, including the early escalations on the left side of the diagram, is kind of this vicious cycle. And that then reduces the total amount of software that can be written, or even worse, it reduces the quality over time. And then if we go back to my first example diagram here, so this one on the far left, there is, or sorry, at the bottom middle of this diagram, there's turnover, right? And it's related to developer skills and training and process issues and other things, right? Developer stress on the far right over here then leads to a reduction in skill level, which might end up ultimately leading to turnover. And so you can see that even though this is a very minor cost, a call was dropped, all of a sudden, over time, it's creating an exponentially higher number of resource drain. And that's why a lot of the value was emphasized on this particular role. Thank you.
Any other questions? 他に質問がある方は。どうぞ。
Thank you for a great session today.
Thank you.
So we usually use value stream mapping to investigate the bottleneck.
Right.
Do you think but value stream mapping doesn't have a system thinking view? So I think it's a great idea to use your loop diagram Do you think those value stream mapping and the dual loop are a kind of substitute or complementary?
Right. So I know we have the value stream map right here. So in the sense, so the answer is that when you create a value stream map, a lot of the time you have the whole system in the room, and you can, right? And it's very infrequent that you say across a number of leaders, 9 leaders of teams of 50 or more people, what's the value stream between them, right? So I think you could use a value stream map in a similar way, drawing value streams for each group and finding out, but a value stream map is very hard to see exponential reinforcing loops or balancing loops.
Yeah.
So when we discover these loops here, and label them, that gives you a better indication, I think, than value stream mapping. I think both tools are very good. One, value stream maps to lean out the process, but causal loop diagrams to show system impacts, especially exponential system impacts.
Yeah, they totally agree. So value stream mapping is easier to create. Maybe we can use both.
Right. Yeah. And if you did this same exercise with somebody unfamiliar with value stream mapping, I think you'll see similar effects, right? So if you're really good at drawing value streams, and then you ask, now what happens? When is it complete? Who then takes over the responsibility later? And then you draw the value stream map over time. People unfamiliar with it could find some significant insights in waste elimination. And actually, in fact, this diagram here, you can't really see it, but when we drew this diagram and showed stakeholders, we eliminated about 30 days of waiting from the process that was outlined in this diagram here. And we had drawn the diagram ourselves to the best of our ability to just communicate where we were waiting, and it was extremely valuable. But like I said, it does not indicate a cycle of any kind, and so there's something higher level that I think causal loop diagramming can solve.
That makes sense.
Thank you.
じゃあ、ディスコードの、質問を読ませていただきます。When drawing a causal loop diagram, should we only write down the facts that we correctly happened that we can observe, or can we also include the speculation?
The last word. Can we also include?
じゃあ、日本語で言います。因果ループ図を書く上で今起きている、観察できている事実のみを書くべきでしょうか、あるいは推測を含めでいいのでしょうか。
Speculation. Yes. So I think you can. The danger of including speculation is that I think you would need to confirm whether your speculation was true, right? And I would make sure that they were that it was outlined properly. But I would start with observable facts and observable quantities, and then I would expand to ideas of speculation. There was certainly a lot of speculation in diagrams that I showed, but they were related to a reasonable certainty, right?
ディスコードで質問された方大丈夫でしょうか。じゃあ次に 移りたいと思います。他に質問のある方いらっしゃいますか？ Any other questions? じゃあ、お願いします。
Thank you. 久しぶり。
Thank you.
Good to see
Thank
you.
you very much. Good, nice to see you. My question is, if the point is the value quantified, but some value is difficult to quantify. So, but on the other hand, we want to put in such a diagram with such kind of, it is difficult to quantify value. How do you do that?
Right. So you can make wider arrows, right? But I would advise you not to, because exponential effects typically grow so quickly that it's very noticeable. And so even though it's a small quantity happening exponentially, typically the organization is going to want to affect those loops because they have such a strong effect. When it's linear, it's often negligible. And so I would just say ignore the strength of the arrow at first, because we saw just experiments that we could run based on the loops that we could change. And more importantly, we shifted funding by connecting different diagrams to each other, right? So I would say don't worry about it.
Okay.
Yeah.
Thank you very much.
Thank you so much.
Yeah, thank you.
他に質問のある方いらっしゃいますか？よし。ありがとうございます。
This may be asking a question you can't answer because it's private information, but you talk about how the causal loop diagram led to you shifting funding. So obviously you learned some substantial things that led to that result.
Right.
And it seemed like you had a problem where you wanted to reduce the queue sizes so that you could reduce the number of calls going to engineers so that they could focus more and not be distracted. So how did that, can you talk about how that worked in practice and the shifting of funding that happened?
Yeah, so we now have much more highly available technical staff that can reduce the size of that queue. Also with built-in flexibility, so we can scale that up and down easily. And what that has resulted in is more frequent releases and higher quality software, because what ended up happening is only real bugs come in or only real problems come in to the development team. They then fix those things and then the call size goes down again. And so, we're also a very seasonal business. And so the number of calls increases dramatically during the summertime when it's hot. And so what you end up seeing is this ability to flex up and flex down now has allowed for consistency inside of the software development team. They are able to write more software and then and create fewer bugs and preemptively fix other problems. And so that investment, so investing in the software team, I think would have just continued to create more issues, because those new team members would create more problems and then they would receive more bugs. And that was kind of what was happening as investment was happening. And so the shift then resulted in a balancing of those things.
So the initial theory was that we need to add more developers because we aren't responsive enough.
Right.
And the actual outcome was to hire. I'm not clear on that part.
Yeah. So so you with call centers, especially, you can create flexibility through like contracting and other things like that. And so you have the opportunity of also categorizing calls based on how technical your staff is. And so the investment was not only into those queues, but also the ability to just scale up capacity and scale down capacity according to rush traffic.
I see.
And that was, very similar to maybe scaling servers during a rush traffic. And because the scaling could happen, we didn't have overspending during the winter months, but we also had the ability to change capacity as things got, much more, because sometimes you just need somebody on the phone being able to say, we'll get to your ticket soon. But a lot of, most of those problems were not related to the software directly.
So you, instead of investing in more engineers, you invested in more support,
Right.
people in your support department, and in scaling that according to the season and demand.
Right. Yeah, the process and the capabilities of, with the ability to change with demand, it allowed for consistent forward movement.
Thank you.
Yeah.
Any other questions? 他に質問のある方いらっしゃいますか？そうですね。じゃあ。It's okay. This session is over. Is it okay?
Okay. Yes. Thank you very much.
Thank you very much.
ありがとうございます。